What are off-by-one errors, and how do boundary conditions cause them? Imagine you are trying to count the number of apples in a basket. If you start counting from 0 and forget to include the last apple, you might miss it completely. That's similar to what happens with off-by-one errors in programming. These are mistakes where a loop or index is off by exactly one, either too many or too few. They often happen when you are working with boundary conditions, which are the edges of your data or input range. Boundary conditions are the first and last items in a list or the start and end points of a loop. When you write a loop to process data, you need to be clear about whether it includes or excludes the boundary points. For example, if you want to process items from 0 up to but not including the length of an array, you should use a less than sign. If you accidentally use less than or equal to, the loop will run one extra time, causing an off-by-one error. A common example is the fencepost problem. If you have 10 sections of a fence, you need 11 posts to connect them. Counting only the sections or only the posts can lead to confusion and mistakes. In programming, this confusion often results in missing the first or last element or trying to access data outside the valid range. Off-by-one errors are tricky because they don't usually crash your program. Instead, they cause subtle bugs like missing data or incorrect calculations. They are especially common when working with loops, array indices, or ranges. To avoid these mistakes, carefully check your loop conditions. Make sure you understand whether your range is inclusive or exclusive at each boundary. Using consistent conventions helps a lot. For example, many programmers prefer half-open intervals, where the start is included but the end is not. This makes it easier to reason about your loops and avoid off-by-one mistakes. You can also do manual walkthroughs of your code with sample data to see if the loop runs the correct number of times. Including boundary cases in your tests is another good idea. Testing with the smallest and largest inputs can reveal off-by-one errors early. Also, be mindful of zero-based versus one-based indexing. Mixing these can cause bugs that are hard to spot. Understanding how boundary conditions work and paying close attention to your loop conditions can save you from many headaches. Fixing off-by-one errors makes your code more reliable and your programs run more smoothly. Keep practicing these habits, and you'll get better at catching these errors before they cause trouble.